Let's move on to 2023, March 2023. So we are dealing with the word delivered. By the way, guys, I'm planning to launch a statistics course soon, a paid course, of course, but that will cover the whole A level syllabus, like from top to bottom. We'll have around 20 videos with question paper solving, just like this, all topics, as well as explanations, solving the course book, etc. So yeah, it'll be worth the money, and hopefully you can get an A star after you see the course. So if you're interested, please do comment below. Then I'll be launching that soon. Okay, so we write it down as double D, then triple E, yeah, followed by LIVR, liver. There are in total 9 letters. Find out the different arrangements in which the 3 E's are together and the 2 D's are not next to each other. So I've repeatedly told you guys, when they say that some things are not next to each other, just ignore them. So I'm ignoring the D's and I'm keeping the E's as a unit. So I have 4 units here, 1 unit here, so in total 5 units. That's 5 factorial. For the E's, it's 3 factorial by 3 factorial. We can ignore that. And for the D's, the spots are, look at the arrows, 1, 2, 3, 4, 5, 6. So it's going to be 6C2 because the D's are identical. Or 6P2 by 2 factorial if you want the longer route, yeah? Or you could find out the total number of ways and subtract it only because there are 2 D's. If there were 3 or 4, it wouldn't have been possible, okay? Next. Find the probability that, like, you could find out the total number of ways and the number of ways where the D's are together and then subtract it from the total number of ways. This is only possible because there are 2 D's. The same wouldn't be possible for 3 E's because I've explained this at the beginning of our video, yeah? If you're seeing this question paper solving video only, you can refer to my, permutations and combinations video, the tutorial. I've explained it there. Anyway, find the probability that a randomly chosen arrangement of the word delivered has exactly 4 letters between the 2 D's. So the contrast from the last one, October-November 2022, variant 5.3, is that there we had at least 5 letters. Here we have exactly 4. So you write down the arrangements like this and just shift the positions of the D's. And we have 4 over here. And then we have, except these 2 D's, 7 letters, out of which 3 are repeats. So 7 factorial by 3 factorial times 4, because 4 arrangements. That's a success. So careful about the word probability. If you have this, you need to divide by the total number of ways, which is 9 factorial divided by 2 factorial for the D's and 3 factorial for the E's. So that's 30240. So for probability, success divided by all possible events, which is 1 by 9. Next. 5 letters are selected from the 9 letters in the word delivered. Find the number of different selections if we include at least 1D and at least 1E. Okay, so 1D, 1E, 1D, 2E's, 1D, 3E's. Then 2D's, 1E, 2D's, 2E's, and 2D's, 3E's. These are all of the possibilities. And since it's not probability, we just, consider LIVR. So from LI we are 4 letters, 3 will sit here, so that's 4C3, and over here we will have a 2 out of the 4, that's 4C2, and over here 4C1, then 4C2, 4C1, and so on. For the last one it's 4C0. If you add all of them, you will get the total number of ways. Okay. Moving on to the next variant. May June 2351. Cocooned, question number 3. Find the number of different arrangements of the 8 letters in the word cocooned. So it's double C, triple O, and any D. There are 6, 7, 8 letters. So 8 factorial divided by 2 factorial for the C's and 3 factorial for the O's. Find the number of different arrangements in which the first letter is O and the last letter is N. Okay, fine. So we keep the first letter as O and the last letter as N. So in between we have 6 letters now, out of which there are 2 C's and 2 O's. So it's going to be 6 factorial divided by 2 factorial times 2 factorial. So a common question that I used to get from my students in the past was, okay, so we are keeping 1 O here and 1 N here. The O is being selected from 3. Does it really matter? Not really. When you put that O there, its work is done. You are only dealing with the other 2 now, okay? Next, find the probability that a randomly chosen arrangement has all three. Oh, so this is probability, conditional probability. Has all three O's together given that the two C's are next to each other. So here the condition is that the two C's are next to each other. Okay, so let's find that out first. The two C's are next to each other. So consider them as a unit. How many units do we have? 6 plus 1 over here, that's 7. So 7 factorial divided by 3 factorial for the O repetitions times 2 factorial by 2 factorial. So that's the condition, given that two C's are next to each other. Now we have to find the probability of the success, that we have all three O's together as well. So how many units now? 1, 2, 3 over here for any D. 4 units, 5 units. So 5 factorial times 2 factorial by 2 factorial times 3 factorial by 3 factorial. This is totally optional because they are identical. You don't need to show this, okay? So the success over here for all O's being next to each other, all O's being together, not next to each other, is 5 factorial, and below we have 7 factorial by 3 factorial. That's that. Okay. Do we have anything else? Oh yeah, we do. Question 2. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. Okay. So 6C6 from the men and 8C3 from the women. That's it. A different committee of 6 people is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Find the number of ways in which the committee can be chosen if there are no restrictions on the numbers of men and women, but it must include no more than 2 of the brothers. Alright. No more than 2. So you can have 1 brother or 2 brothers, but not 3. Okay. So the easy way to do this is we are going to find out the committee with 3 brothers and then subtract it from the total number of ways. So suppose I've taken all 3 brothers. Now I have 3 other men left. So 3C3, I've taken all the brothers. And then I have 3 men left and 8 women. So that's 11 people in total. From the 11, I'm going to pick 3. So that's 11C3. And the total number of ways is, irrespective of the brothers, 6 plus 8 is 14. So 14C6 minus 3C3 times 11C3. So we get 2838. And the complicated root is doing 0 brothers, 1 brother, and 2 brothers in excuse me, individually. So ignoring all 3 brothers, I have 3 men and 8 women. So that's 11 people. 11C6. Okay, 0 brothers. And then we have, I'm taking 1 brother out of the 3. That's 3C1 times 11C5, 5 others. And then I'm taking 2 brothers, which is 3C2 times 11C4. That also gives you an answer of 2838, okay? Next, moving on to May, June 23, paper 5.2. Oh yeah, if you want access to all these are actually available on Patreon just for $20 monthly subscription. So yeah, you can actually solve alongside me, because in the mark scheme, the answers are only there most of the time. But here you have detailed working of how I did everything. So yeah, it's gonna be very helpful for your exams, especially in the next May, June 2025 series. Yeah, and I'm looking forward to you guys supporting me there. Also, I plan to launch another tier where you can get access to one subject only for like $5 per month. That's gonna be very popular, I think. Anyway, in a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. So a team of 7 people is selected from these 25 people to take part in a competition. So it's like the one where we selected the football team in my example, right, initially. So exactly 1 swimmer, at least 4 cyclists, and at most 2 runners. So runners can be 2, 1, or 0, and cyclists can be 4 or more. So 1 swimmer for sure, and then suppose we have 4 cyclists and 2 runners, that's 7. Then we can decrease the number of runners and increase the number of cyclists. So 5, 1 or 6, 0. And then you know the rest. 6C1, 1 swimmer out of these 6. Then 8C4 times 11C2 and so on, okay? Moving on. For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for a photograph. How many different arrangements are there? If the swimmers stand together, cyclists stand together, and runners stand together. So there are 3 groups in total. For them, we have 3 factorial. For the 2 swimmers, we have 2 factorial. For the 3 cyclists, we have 3 factorial. And for the 4 runners, we have 4 factorial. Notice how I'm not dividing by 2 factorial, 3 factorial, or 4 factorial, like the previous sums with letters. The reason being, these guys are all identical, okay? How many different arrangements are there of the 9 people if none of the cyclists stand next to each other? Okay, so I told you again that whenever people can stand next to each other, just ignore them. So you have 2 swimmers and 6 runners, so that's 6 factorial. And then you have 7 arrows, but 3 cyclists, so that's 7p3 because their arrangement matters and they are not identical, okay? It's that. Moving on to Major 23, paper 5.3. So Casablanca. Find the number of different arrangements of the 10 letters in the word Casablanca in which the 2 C's are not together. Okay. So they're not next to each other basically. So we're going to ignore them. So Casablanca, right? 2 C's, 4 A's, SBLN. So I'm ignoring the C's, so I have 4 A's and SBLN. That's 8 factorial divided by 4 factorial because of the repeats. Then times, I have 9 arrows, as you can see. 9 arrows. One more always. So that's 9C2 because the C's are identical. Or you could find out the number of arrangements where the C's are together and then subtract from the total, okay? Next, find the number of different arrangements of the 10 letters in the word Casablanca, which have an A at the beginning, an A at the end, and exactly 3 letters between the 2 C's. Okay. So A at the beginning and A at the end. So I fix that initially. Then I start with the C's, the arrangements. 1 C on the second blank, 3 gaps, then another C, and so on. I can do this in 4 ways. So I'm going to multiply it by 4. And how many letters do we have in the middle? We have 2 extra A's and SBLNs, so that's 6 letters. For that we have 6 factorial, and for the 2 A repetitions we're going to divide by 2 factorial. So that's that. We're getting 1440, okay? That's it. Next, 5 letters are selected from the 10 letters in the word Casablanca. Find the number of different selections in which the 5 letters include at least 2 A's and at most 1 C, okay? So at least 2 A's. So it has to be 2, 3, or 4. And at most 1 C. So C can be 1 or 0. So for 2 A's, 0 C's, 2 A's, 1 C. 3A, 0 C, 3A, 1 C. Or 4A, 0 C, 4A, 1 C. And for the other blanks that are empty, we are going to use the letters SBLN. So 4C3, 4C2, 4C2, 4C1, and so on. So the total answer is 25, okay? So that's that. Moving on to ON2351. We don't have much variance left. We have 3 on this end and 7. 10 more sums approx. Hopefully this is very productive for you guys. If you want more of this content, please comment below. And if you like the content, please remember to like the video, share with your friends, subscribe to the channel. It actually helps a lot with the algorithm. I really want to reach 100k subs. We are at like how many subs right now? 21k or something? Kind of like that, I guess. Yeah, we're 21k 700, but a lot of you don't subscribe to the videos, honestly, and that actually breaks my heart. Because I'm doing this just for you guys. I'm almost done with med school. I'm going to be done this November. But yeah, I still want to continue this till I get 100k. And then I'll see what I can do. Maybe I'll leave. But you know, so every subscription matters, okay? So please try to support me, guys. It actually means a lot. If you can't on Patreon, then just at least support me on YouTube. Thank you. Okay, so in a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y. Rajid, Sue, and Tan are 3 of these friends. The 8 friends will be divided into 2 groups of 4, 1 group for table X and 1 group for table Y. Find the number of ways in which this can be done if Rajid and Sue must sit at the same table as each other, and Tan must sit at the other table. Okay. So basically, Here's the thing. Suppose Rajid and Sue. It wasn't specified whether they sit on table A. Okay, table X. So it can be on table X or table Y. That is why I have an into 2 over here. Okay. That's the first thing you need to know. Next, Rajid and Sue must sit at the same table as each other. Fine. So I make them sit at table X. So we have 2 more slots available and 5 friends, except Rajit, Sue, and 10, of course. So for the 5 friends, we have 2 seats. So that's 5C2. And their arrangement doesn't matter because they just asked how can they be divided, yeah? And then we have 3 seats left at table Y, so we can just go for 3C3. You could opt to fill up table Y first. You could go for 5C3 times 2C2. That would give you the same answer. Now, why did I multiply by 2? Because Rajid and Sue could also sit at table Y, and 10 could sit at table X. That's why it's multiplied by 2. That's the general idea. Next, when the friends arrive at the restaurant, Rajid and Sue now decide to sit at table X on the same side as each other. Tan decides that he does not mind at which table he sits. Find the number of different seating arrangements for the 8 friends. Fine. So, Rajid and Sue decide to sit at table X. Okay, it's fixed now. And on the same side. And now Tan decides that he does not mind at which table he sits. So he can either sit at table X or Y. So this is a bit complicated. Let's try to break this down. Okay, this is a bit hard. Come on. So Rajid and Sue, suppose I make them sit on this side of the table. Okay, table X, this side, same side. So we have 6 remaining friends and 6 seats. So 6C2, I make 2 people sit here. And then 4C4, I make the other 4 sit on the other table. Because Tan doesn't mind. Tan's being the good guy, okay? Everyone be like Tan. Don't be like Rajid and Sue, okay? Next. What about now? Because they use the word arrangements, okay? So students, whenever you see the word arrangements, that's when permutations come in, okay? So, why do we have 4 factorial? Why do we have 4 factorial? This is the important part. Because of these guys over here. 4 factorial because these 4 guys can interchange their positions, okay? The 4 people we sat at table Y. Okay, next. This 4 factorial is for the 4 that sat at table Y. What about this 2 factorial? The first 2 factorial is for the other 2 friends that sat at this side of table X, okay? So there you go. And what about this 2 factorial? This is for Rajid and Sue because they only decide to sit at the same side of the table, which is here, but they can interchange their positions. And what about this 2? This is because Rajid and Sue can also sit on this side of the table. So that's the basic idea. So 6C2 times 4C4 times 4 factorial for these guys, 2 factorial for these guys, 2 factorial for these guys, and times 2 because Rajid and Sue could also sit on this side as long as it's the same side of the table, okay? Hopefully you guys understood. It's 2880. Moving on. As they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of different arrangements if Rajid and Sue stand next to each other. So they're probably dating, guys, because they can't leave each other. Okay, so Rajid and Sue stand next to each other, but neither is at the end of the line. Fine, okay. So we have 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. So Rajid and Sue, they're together, so they will move as a unit, but not at the ends. The first one and last one, they can't stand there, okay. So they have 1 position, 2nd and 3rd blank, 3rd and 4th blank, 4th and 5th, 5th and 6th, 6th and 7th, but they can't occupy the 8th one. So in total, 1, 2, 3, 4, 5 positions. Now for Rajid and Sue, there's a 2 factorial because they can interchange places. And for the other 6 friends, we have 6 factorial. So it's pretty straightforward. 6 factorial times 2 factorial times 5, which is 7,200. That's that. Okay. I prefer this method because it's like you can visualize. In permutations and combinations, always try to visualize your answer. Always try to visualize the arrangements. It will help you guys a lot, trust me. Okay, ON2352 now. Yeah. Let's go. Question 7. I will say one thing though, the permutations and combinations for stats have progressively become more difficult over the few years, okay? So let's do this. Andromeda. It's the name of a galaxy. So, one variation I missed while I was teaching initially was that of vowels and consonants. So, Andromeda, double A, double D, Enrome. No consonant is next to another consonant. Okay. So, what are the vowels here? We have two A's, one O, and one E. So, okay, for the vowels, we are going to ignore the consonants first because they said they can't be next to each other. So for the vowels, it's 4 factorial by 2 factorial due to the A's, which are repeats. And then we input the consonants, which are D, D, R, M, N. So we have 5 arrows and 5 consonants. So that's 5 factorial, 5p5 or 5 factorial, divided by 2 factorial because there are 2 identical D's. That's that, 720. Next, find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and the D's are not together. Okay, so there's an A at each end, fine. And in the middle, we actually have, I'm going to ignore the D's, right? Because they're not next to each other. So we have Enrome in the middle. So that's 5 factorial for Enrome. And for the D's, we have 1, 2, 3, 4, 5, 6 arrows, the blue arrows. I'm not considering the N's because those are occupied by A. So that's 6c2 or 6p2 by 2 factorial if you want that root. The other way was you could subtract the D's being together from the total number of ways where the A's are then, but I don't personally prefer that, okay? Next, 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability. Oh, this is probability again. Just like that sum we did, activated, same. I think it was this one, yeah. ON 202253. We have that again, ON 2352. Find the probability that this selection of 4 letters contains at least one D and at exactly one A. So we have 2 A's and 2 D's. So exactly one A. 1 A and at least one D. So 1 D or 1 A and 2 D's. So there are some other blanks left where Enrome can be allocated. So here it's going to be 5c2, here it's going to be 5c1. And for these, since it's probability, the number of A's and D's do matter. So here we're picking 1A out of the 2, so that's 2c1, and 1D out of the 2, that's 2c1 again. And here it's 2c1 times 2c2 times from Enrome 1 letter out of the 5, that's 5c1. Okay, there you go. 25. That's 50, and since it's probability, we need the total number of events in the denominator. So picking 4 letters out of 9, which is 9c4, we get 25 by 63. Moving on to the last variant in this year, 2023. Let's do this. Jay and his wife Kaz are having a party. Jay has invited 5 friends and each friend will bring his wife. Okay. At the beginning of the party, the 12 people will stand in line for a photograph. How many different arrangements are there? Of the 12 people, if Jay stands next to Kaz and each friend stands next to his own wife. So there are 6 couples. For that, we have 6 factorial. And for each couple, they can alternate their positions. So 2 factorial into 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 2 factorial or 2 factorial to the power 6. So that's 6 factorial for the 6 couples, the 6 units, times 2 factorial to the power 6. That's the answer. How many different arrangements are there of the 12 people if Jay and Kaz occupy the 2 middle positions in the line? With Jay's 5 friends on one side and the 5 wives of the friends on the other side. Okay. So Jay and Kaz occupy the 2 middle positions. So there are 12 spots for 12 people, and the middle spots are 1, 2, 3, 4, 5, 6, the 6th and 7th spot. So Jay and Kaz want to be here. The 5 friends, Jay's 5 friends on one side, and the 5 wives on the other side. So for these 5 friends over here, it's going to be 5 factorial. For the 5 wives, it's going to be 5 factorial. And for J and Kaz, J can either choose to be beside his friends, or J can either choose to be beside the wives. Which Kaz would not like very much, by the way. But it's still a possibility. So that's 2 factorial for them. Okay, 2 factorial for them, 5 factorial for the guys, the bros, and 5 factorial for the wives. And why this into 2 here? Can you guys figure out? Because the wives and Jay's friends can also interchange their positions. This one and this one, right? These are also interchangeable. That is why we have an into 2. Next. For a competition during the party, the 12 people are divided at random into a group of 5, a group of 4, and a group of 3. Find the probability that J and Kaz are in the same group as each other. Okay. So this is like the word crocodile, like Majon 202252, but with people instead. So we have 3 groups, a group of 5, 4, and 3. So we are going to consider J and Kaz in the group of 5 people, then in the group of 4 people, then in the group of 3 people, and so on, like this, okay? So J and Kaz being in the group of 5 people, then we have 10 people left. So 10C3 times 7C4 times 3C3, that's 4,200. J and Kaz in the second group, that's 10C5 times 5C2 times 3C3, 2520. And then J and Kaz in the last group, so that's 10C5 times 5C4 times 1C1, that is 1260. So the total number of ways in which J and Kaz are in the same group are 7980. And what about the total number of events anyway? We are just selecting people, right? So that's 12C5 times 7C4 times 3C3 down below. That is 19 by 66, okay? That is all.